Have you ever found yourself driving long stretches and thought, I wish the car would just drive itself? Well, you wouldn't be the only one. From as early as the 1920s, humanity has been conceptualizing and testing different ways in which we wouldn't need to be the one steering the wheel. By the 2010s, the first commercially available self-driving cars hit the market, boasting autopilot capabilities such as adaptive cruise control, lane centering, and automatic lane changes. However, as we venture further into the realm of autonomous vehicles, we encounter a crucial challenge. Traditional approaches are often reliant on deep learning models, and this brings about some core limitations. These models excel in predictable scenarios like maintaining lanes or navigating familiar routes. However, driving is a constant process that is reliant on environmental factors for any decision making. It demands a more adaptive approach. Enter Next-Gen Velocity, stepping in to address this challenge with a novel approach. Instead of the conventional deep learning models, we harness the power of state-of-the-art reinforcement learning algorithms. These algorithms learn from experience, adapting to their environment dynamically. To illustrate our approach, we utilize the Donkey Car Simulator by OpenAI Gym, offering a diverse set of tracks for our self-driving models to navigate through. 3 distinct algorithms were trained and rigorously tested to measure feasibility and performance. Those being Double Deep Key Network, Truncated Quantile Critics, and Proximal Policy Optimization. Training these models was a lofty undertaking, and we experienced several roadblocks along the way. This ranged from being unable to use cloud-based platforms to train the models, RAM depletion during training, and very lengthy training times. We worked around these obstacles and performed 40 to 45 different experiments on our chosen models, fine-tuning the hyperparameters to improve performance each time. After extensive evaluation, Truncated Quantile Critics emerged as the standard performer, showcasing unparalleled results with an average reward exceeding 8,000. From the demonstration shown, you can see just how smoothly the car trained on TQC performs. Our solution doesn't just follow pre-trained patterns, it learns, adapts, and makes decisions based on real-world experiences. Regardless of the track shape, the autonomous car can stay within the lane, adjusting its orientation, direction, and speed as required. As we continue to push the boundaries of autonomous driving, the adoption of reinforcement learning shows promise in its potential to elevate capabilities. With this technology, future autonomous cars will not only drive themselves, but will anticipate your needs, navigate seamlessly, and evolve with every journey. The dream of a fully autonomous car may well become a reality at last.